Okay, so we're here. I'm going to do some more of 3.4, the chain rule. There's some pretty messy ones at the end, so I'll do those. Introduce 3.5, which is on implicit differentiation. So I have until Wednesday for that. So overall picture for this week, aiming to get up to 3.6, and a quiz again on Friday. So again, looks like we have 11 sections total. So I think it takes us 4 weeks. So week 2 out of the 4 would be up to here, I guess. Okay. So looking ahead, our next exam is on the 23rd, looks like. Okay. And a reminder, next week, Thursday, there's actually no class, not just for me, it's for all of CSM. So if you have any classes on Thursday, they're canceled. It's a flex day for teachers. So teachers we have to quote unquote show up on Zoom, obviously, but students don't have to. Okay. All right, so back to the chain rule. Okay, so I mentioned 3.431. I just talked about it at the end yesterday, but now let's actually do it. Okay, e to the t sine of 2t. T sine of 2t. All right, so it's not just e to the x. We know the derivative of e to the x is e to the x. If you have e to something more complicated, it's now going to be a chain rule thing. Okay, so the outside function is the exponential function. The inside function is this stuff, but the inside function is a product rule, t sine of 2t. And there's even a chain rule on top of that because I have to differentiate 2t. All right, so first, when you differentiate, you copy the original. That's how the exponential works, right? So it's e to the t sine 2t. Then it's times the derivative of the inside function. The inside function, t sine 2t, is a product. So this is the first function. This is the second function. So here we go. First, t times the derivative of the second. So what's the derivative of sine 2t? It's cosine 2t times 2. So where's that extra times 2? It's times the derivative of the 2t. So sine has an inside function, 2t. So I can't just stop at cosine of 2t. I have to multiply by the derivative of the inside function. Derivative of 2t is 2. Okay. And this is in the process of doing a product rule. So it's plus the second function, so sine of 2t, times the derivative of the first function, but the derivative of t is just 1. So it's times 1, which means you don't really have to write it. Okay, that's essentially it. The last little cleanup would be maybe to put the 2 in front of the t. So 2t cosine 2t plus sine of 2t. And that's pretty much about it. So just leave your answer like that. Okay, so there's a chain rule, there's an exponential function. It's not just e to the x. The derivative of e to the x is e to the x. You have e to another function, then the exponential function says, go ahead and copy this. That's all the same. But now you have to multiply by the derivative of the exponent, and that's all this stuff. All right, 39 is a good one because this is 3 layers, as it were. There's a tangent, secant, cosine. So first you differentiate, you go outside in. You take the derivative of tangent. So what's the derivative of tangent? Secant squared. You copy all the rest of the stuff. And then the chain rule says it's times the derivative of the inside, so you would differentiate secant. Then after that, you take the derivative of cosine. You just chain them together. That's why it's called the chain rule. Okay, so derivative of tangent, secant cosine t. So you put secant squared of secant cosine t. Don't do anything to this yet. Okay, so this part is just a copy job. Just copy exactly this thing right over here. So notice it's secant squared of secant cosine of t. Okay, now I'm done with the tangent. I'm finished with that. So it's times the derivative of the inside. The inside is secant cosine t. So this is a composition of functions in itself. Okay, so what's the derivative of secant? It's secant tangent. So you put secant cosine t, tangent cosine t. Okay? If it said secant x, you would go secant x, tangent x. If it's secant cosine t, you go secant cosine t, tangent cosine t. You don't touch the inside yet. Okay? And one more time, now it's times the derivative of the inside function. Okay, so what's the derivative of cosine t? Negative sine t. And now finally you're done. Okay. So this is the final answer. Okay, so there are 1, 2, 3 functions involved with this. Okay, the tangent, the secant, and the cosine. So derivative of tangent is secant squared. So secant squared, copy all that. Secant cosine t. Okay, now you're done with tangent. So now the rest of the problem, you're asking what's the derivative of the inside, which itself is a composition. Secant cosine t. So derivative of secant is secant tangent. So secant cosine t, tangent cosine t. Okay, so now you're done with this function. Now it's times the derivative of the innermost function, cosine t, negative sine t. And now you're finally done. Okay. Now, 45, as I think I mentioned it yesterday, this one really shows how the chain rule works. There are 1, 2, 3, 4, 5 functions in this. Okay, so it's just like, you know how we normally say f of g of x? It's f of g of h of I of j of x. As it were, you got 5 functions. Here are the 5 functions in order. The outermost is the cosine. The next one is the square root function. The third one is the sine. The fourth one is the tangent. And the fifth one is multiplying by pi x. Okay? So you just work your way from outside to inside. So you ultimately start up with cosine. After that, you do the square root function. After that, you do the sine. After that, you do the tangent. After that, it's the pi x. All right, so here we go. What's the derivative of the cosine? It's negative sine. So negative sine. And then what am I going to put? This entire thing. Square root sine tangent pi x. Okay, you leave that part alone. Okay, so again, derivative of cosine is negative sine. Then you copy all this. All right, so I'm done with the cosine. Now I have to differentiate square root. Okay, now to make things much easier, I don't want to rewrite that. Square root means raising to what exponent? It's to the 1/2. Okay, so pretend it's sine 10 pi x, all of that to the 1/2. All right, so here we go. 1/2 sine 10 pi x to the negative 1/2. That's how you differentiate a square root function. And one more time, sine of 10 pi x raised to the 1/2. So differentiate 1/2, blah, 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 to the negative 1/2. Okay, so now I'm done with the square root function. So this cosine is gone, the square root is gone. Now I'm at the third function, sine. So how do you differentiate sine? Cosine. So cosine of 10 pi x. Okay, so I'm done with the cosine, I'm done with the square root, I'm done with the sine. I'm now at the level of tangent pi x. So what is the derivative of tangent pi x? Secant squared of pi x. Just multiply them all together. That's why it's called the chain rule. Chain them all together. Okay, so I'm done with 1, 2, 3, 4 functions. The last function is pi x. What's the derivative of pi x? Pi. And finally, we're done with the whole thing. And yeah, just leave it like this for now. Okay. For something weird like this, I would relax the rule that says, oh, you got to not have a negative exponent. And for something this bad, you can barely even copy it. So for this one, I would say just stop. Okay, so you just work out or in. Derivative of cosine, negative sine. Copy the rest of it, square root, blah, 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 blah. Okay, cosine's finished. Now I go to the next function, square root, which means blah, blah, blah to the 1/2. Okay, so 1/2 sine, all that stuff, to the negative a half. Okay, then keep going, times derivative of sine. Derivative of sine is cosine. So cosine tan pi x. Then I differentiate tangent pi x. Secant squared pi x. And then multiply by pi. Okay, Malak, you raise your hand, so you want to unmute yourself. I can't see the chat right now under this mode, so when I'm in share screen, I can't see the chat. So do you want to say what your question might be, please? Malak, did you have a question or no? No? Well, let me stop here. Maybe I can't be heard. I guess I can be heard. All right, well, since I'm in this mode again, let me check the chat. And okay, you don't have this. Okay. How do you know when to use a chain rule? When you see a composition of functions, a function of a function, as it were, like that. Okay. That last one was pretty bad, I admit. Okay, it was 5 levels deep. So let me go back to sharing the screen. Okay, one thing to watch out for, let's say over here, if it said tan x secant whatever, that would not be a composition of functions. That would just be a product root. So suppose it's a tan x secant x, or t rather, tan t secant t cosine t. That would all be multiplication. There'd be no chain root. It would just be product root. Okay. When it's like this, that's a composition of functions. This is not a multiplication. It's the tangent of the secant of the cosine of t. Okay. All right, then 53 was the last one I was going to do, and then I was going to introduce the next section, 3.5, implicit differentiation. Okay, y equals sine of sine x at the point pi 0. So that game again, find the equation of the tangent to the curve at the point pi 0. Okay, so recurring theme. So we take the derivative, plug in to find the slope, and then do the point slope form. Okay, so y prime, what's the derivative of sine of something? It's cosine. So you put cosine of sine x times the derivative of the inside function, which happens to again be sine x. It's okay. It's okay to have sine of sine or whatever. So what's the derivative of sine x? Cosine x. So the derivative is cosine of sine x times cosine x. Now be careful. This one here is a multiplication. This is not a multiplication. This is a composition. Cosine of the sine of x. All right, now they want me to plug in pi. So put a pi right there. So cosine of sine of pi times cosine pi. Sine of pi is 0. So I'm taking the cosine of 0 times the cosine of pi, which is -1. So cosine of 0 is 1 times -1 is -1. So the slope is -1. All right, point slope. Y minus y1 equals m times x minus x1, and you can stop right there. All right, so that is 3.4. I'm going to start 3.5, which is on implicit differentiation. And before I talk about that, maybe you might be thinking there's an English word that's the opposite of implicit, which is explicit. So we could say that. So all the derivatives we've been doing so far are explicit differentiation. And so what is implicit differentiation? Okay, so maybe by introduction, let me show you what's going on in the book. So implicit differentiation. Let me show you what the problems look like. So how is this any different? Okay, and while we're at it, I might as well show you from the text. So what do we have to do? 3.5, 1 to 33, 49 to 52, 54, 56, 57, something like that. Mark this off here. Okay, so this is page number 215, looks like. Okay, so let me hold it here. And a little bit farther down. And a little bit farther down. Okay. And then on the next page. Let's see, there's that. And up to 60. A little bit below that. And we don't have anything on that page. Okay. Anyway, implicit differentiation. Look at the kind of equations they give us. You have x and y are all mixed up. Okay. Now, before it was always y equals a function of x, or y equals f of x, or different letters. S is a function of t, p is a function of q, or whatever. But here you've got x's and y's all mixed together. And you say, why don't you just solve for y? Well, sometimes you can't. It's either too difficult or impossible, right? Like some of these, it's either impossible or very difficult to solve for y. Y is a function of x. So if you have y as a function of x, that's explicit differentiation. Okay, but here you've got x's and y's all mixed together. You can't easily solve for y. So, but we still want to talk about a derivative. So that's where you would have something called implicit differentiation. Okay. Now, something else about implicit differentiation. So far, we've only dealt with functions, but what if you have something that isn't a function? Okay, so page 208. Let's look at x squared plus y squared equals 25. That's a circle, center of the origin, where the radius are 5. It's not even a function, right? You could break it up into two functions, like that and like that, because they got f of x equals square root of 25 minus x squared, and g of x is negative square root of 25 minus x squared, okay? But ultimately, it may not be a function, or if it is a function, it's too difficult to solve, okay? I'm going to show you something here. X cubed plus y cubed equals 6xy. It's a real funny looking thing. It goes like that. There's a name for it. Don't write it down. It's called the Folium of Descartes. Don't write that down. Don't memorize it. I haven't memorized that. It's not really worth memorizing. This is not even a function. Although you could break it up into a function, I suppose. You could make it look like that and like that. Okay. So we're saying, okay, we cannot solve for y, or maybe it's too difficult. We can say there's a function implicitly. Y implicitly is a function, okay, like this. Now, normally we say y equals f of x. Take a look at what they did over here. I claim this is exactly the same as this. Okay. We're used to saying y is f of x, right? So instead of x cubed plus y cubed, instead of y, they put f of x cubed equals 6x f of x. Notice that? Okay. So we're saying we can write y implicitly as some function f of x. Maybe we can't solve for it, but it's there. We can break it up into this and this. Okay. So how do we differentiate functions now when it's not y explicitly as a function of x, but you have x's and y's all mixed together? All right, so the text sort of goes over that already here. But let me show you what I have here. And it gives you the algorithm. Suppose I want the derivative of f of x cubed with respect to x. Okay. So how do I differentiate f of x cubed with respect to x? Well, that's chain root, right? 3 comes down, f of x squared, then times the derivative of the inside, which I can write as f prime of x. Okay, that's a chain root. Or assume we have y equals f of x implicitly. Okay, we can't write it easily like x sine x or something like that. But if I call that y, every time I see f of x, I'm going to replace it with y. It would look like this. The derivative of y cubed with respect to x is 3 f of x is y squared. And then times f prime of x, which I can write as y prime, or 3y squared dy dx. Okay. So let's look at big picture. In the homework, they're just going to show me y cubed. How do I differentiate y cubed? It's 3y squared times either y prime or dy dx. In this section, though, I want all of you to write dy dx. And if you don't write dy dx, sorry, that's my rules. I might take off for it. Okay. I want you to get used to dy dx, and that helps you later on when we do another section called related rates. I want you to get used to the d notation. Okay. So calculus rules, when you do this, you can write y prime. Melvin-Hom rules, you have to write dy dx. Okay, so if you write y prime, I'm not going to accept it. You have to write dy dx. Okay, so overall picture, you're going to have equations that have x and y all mixed together. If you want to differentiate x squared, do the derivative as normal. But if there's a y involved, you have to multiply by dy dx after that. Okay, calculus rules, yes, you could write y prime, but I want all of you to write dy dx. Obviously, when I grade the quiz or test or homework, there are 43 of you. I would rather that everybody writes the same thing, dy dx. Yeah, it's more work. It's more writing to write dy dx, but I'm setting you up for a future section to get used to this Leibniz notation, the d stuff. Okay, it's called the Leibniz notation, L-E-I-B-N-I-Z. I wrote it for you before. You don't have to memorize it or whatever. Okay, so let me show you a perfect example right away by doing some of this stuff. Number one, 9x squared minus y squared equals 1. Whoops. Okay, find the derivative. Okay, so what we're going to do is differentiate both sides with respect to x. Okay, if two things are equal, their derivatives are equal. All right, so please notice carefully how this works. What's the derivative of 9x squared? 18x. What's the derivative of negative y squared? Because there's a y, implicitly it's a function of x. You go negative 2y times dy dx equals the derivative of the right side is just 0. Okay, now algebraically solve for dy dx. That's all. Okay, so one more time. If you have an x involved, do the usual derivative that we've been doing before, 18x. If you have a y involved, negative 2y, y is a function of x implicitly. We can't write it as a function, but implicitly it's a function. So by the chain rule, you have to multiply by y prime or dy dx. Again, for now, I want you to write dy dx. Now it's just algebra. Add this to both sides. 18x equals 2y dy dx. Divide both sides by 2y. So dy dx is equal to 9x over y. Final answer. Okay. And now this is our first instance of the derivative involving x and y. Before, all the derivatives, when you had y explicitly as a function of x, the derivative expression only involved x. So we never plugged in y. Now, however, the derivative expression has x and y. So now if they say we're at the point, 3 comma negative 10, then you plug in 3 and negative 10 to find dy dx. Okay, so this is called implicit differentiation. Before it was explicit differentiation. All right, so x squared minus 4xy plus y squared equals 4. Okay, so the game rule is this. If the derivative involves x, just take the regular derivative with respect to x. If the derivative involves y, you have to multiply by dy dx. Okay, so the derivative of the right-hand side is easy, 0. Okay, if two things are equal, their derivatives are equal. So it's almost like we're adding to our bag of tricks of what you can do to an equation. You have a left-hand side and a right-hand side. And ever since Algebra 1, you say to yourself, whatever you do on this side, you do the same thing on this side, right? So your first algebra class, you say, okay, add the same thing to both sides, subtract the same thing on both sides, multiply the same thing, divide the same thing, right? Then later on, you got more fancy, square both sides, take the square root of both sides. Then later on, take the log of both sides, right? Okay. Well, now we're taking the derivative of both sides. If two things are equal, the derivatives are equal. Okay. So 0 is easy, right? Derivative of the right-hand side is 0. Now, the derivative of the left side. So what's the derivative of x squared? 2x. Okay. Now, this gets tricky. Okay. I'm differentiating negative 4xy, that whole thing. It's a product. First function, second function. So this red underline, I'm calling the first function negative 4x, and this little underline is y. So first, so plus a negative 4x times the derivative of the second. So the derivative of y is 1 dy dx. Because there's a y involved, you have to tack on a dy dx. Plus second function, y, times the derivative of the first. So what's the derivative of negative 4x? Just negative 4. And since that involved the variable x, I don't need to tack on anything extra. Okay? It's only when there's a y involved, you have to multiply by dy dx. Okay, now I have to differentiate y squared. Again, so what do you mean by differentiate? Differentiate means take a derivative. Okay, so derivative of y squared is 2y, and because a y was involved, you have to multiply by dy dx. And yes, that equals 0. Okay, so I'll run through all of that one more time. Okay, so if the derivative has an x, just take the derivative as usual. If there's a y, though, you have to multiply by dy dx. The reason is the chain root. It's part of the chain root. Okay, if you don't understand that idea, just get the algorithm. The algorithm is whenever there's a y involved, you have to multiply by dy dx. All right, so derivative of x, the derivative right-hand side is 0, right? Derivative 4 is 0. Now, differentiate the left side. Derivative of x squared, 2x. Now, this is a product, negative 4xy. So I'm calling the first function negative 4x, the second function y, or f and g if you would. So copy the first function, negative 4x, and then times the derivative of the second. So the derivative of y is 1 times dy dx, because there's a y there. Plus second function y times the derivative of the first. What's the derivative of negative 4x? Negative 4. And since there was an x there, no need to put anything extra after that. Okay. Plus the derivative of y squared, 2y dy dx, because there's a y there, equals 0. Now, algebraically solve for dy dx. Okay, so the name of the game here is everything with a dy dx stays on one side, everything else moves to the other side, and of course you prefer to have as few negative symbols as possible. So both of these dy dx's are already positive, so I'll throw these two guys over. So 2x moves over, it becomes a negative. The negative 4y moves over, becomes a positive. Okay, so this then that I have circled in red goes over as a negative. This goes over, it'll become a positive. And let's see, that one and that one both have a dy dx, right? So I factor out the dy dx, and I'm left with negative 4x plus 2y. Okay, so dy dx on the left side, negative 4x plus 2y. On the right side, everything that does not have a dy dx, that one and that one. Okay, now just divide both sides by that, and you're done. So dy dx is negative 2x plus 4y. I decided to write it as 4y minus 2x. It's a little bit cleaner. And divided by, and I decided to write that as 2y minus 4x. That's a little bit cleaner also. Okay, I'll let you stop there, although technically you could factor out a 2 and keep going. Okay, and then after that, it does not look like you can cancel anything. So that's good enough. We'll just stop right there. Okay, number 11 is the next one I was going to show you. Check something over here. Y cosine x equals x squared plus y squared. Okay. Yes, technically, if you could solve for y, say, what do you have to do this implicit differentiation stuff? How about if you just solve for y? Yes, if you can solve for y, it'd be a lot easier. It's just that in something like this, you can't solve for y easily. So we're stuck with this implicit differentiation. Okay, so differentiate the left side, differentiate the right side. Okay, y cosine x. Product root, right? It's a product. First function, second function. So copy the first times the derivative of the second. So what's the derivative of cosine x? Negative sine x. And since there was an x involved, you don't need anything extra. Plus second function, cosine x, times the derivative of the first. So what's the derivative of y? 1, which means I don't have to write it, times dy dx, because there was a y involved. Okay, so again, product rule, y cosine x, that's a multiplication. So first times derivative of the second, there it is. And since the variable was x, no need to put anything else. Plus second function, copy it, times the derivative of the first. What's the derivative of y with respect to x? 1 times dy dx. Equals the derivative of the right side. So what's the derivative of x squared? 2x. What's the derivative of y squared? 2y times dy dx. Right, so we got dy dx is all over. So now I have to algebraically solve for dy dx, which means everything with a dy dx on one side, everything that does not have a dy dx goes on the other side. And you prefer to have as few negative symbols as possible. Now, I notice if I bring this one over, which I decided to do, this will become a negative, right? But that's positive. And if I bring that over, it becomes a positive. So I get the fewest number of negatives by putting dy dx on the left side. Sometimes it's more ideal to put the dy dx on the right side just to have fewer negative symbols. Okay, so I'll move this one over, it becomes a negative. Move this one over, it becomes a positive. So the right-hand side now has 2x plus y sine x. Okay, and then if I bring this one over, it becomes a negative. I will factor out the dy dx. There's a dy dx here, there's a dy dx here. So I factor out the dy dx, and I will have cosine x minus 2y, right? I bring that over, it becomes a minus, equals all this stuff. Okay, and then divide both sides by cosine x minus 2y, and finally you have it. So there's my final answer. Dy dx equals 2x plus y sine x over cosine x minus 2y. So that big mess there is my final answer. Okay, I was going to show you just one more, and then I'll stop after that and let you ask questions, okay? So if you have a question about this or any other previous section, you may. So it might take me 3 or 4 minutes to finish one more. So if you can think of something for question-wise, you want to ask me something, that'll probably be the last 10 minutes of class, then go ahead and do so, okay? But I was now going to show you 19, because this one can get real weird. So sine xy equals cosine of x plus y. Okay, so this one gets pretty weird. All right, so this is a chain rule. So how do I differentiate sine of xy? Cosine of xy, then by the chain rule times the derivative of the inside. The inside's a product, x times y. So first times the derivative of the second, x times the derivative of y. So what's the derivative of y? 1 times dy dx, because there's a y involved. Plus second function y times the derivative of first. So what's the derivative of x? 1. So you don't have to write anything. And again, since there was an x involved, you don't have to put anything extra after that. All right, so one more time, derivative of sine is cosine xy, then times the derivative of the inside, that's the chain rule, and the chain rule differentiating xy is a product, x times y. So x times the derivative of y, 1 times dy dx, plus second function y times the derivative of the first, derivative of x is 1, equals the derivative of the right-hand side. So what's the derivative of cosine x plus y? Negative sine x plus y. And then by the chain rule again, it's times the derivative of the inside. So what's the derivative of x? 1. What's the derivative of y? dy dx. 1 times dy dx. Okay, now it gets pretty bad. In order for me to complete this problem, I have to distribute. So cosine xy times that and times that. Negative sine x plus y times that times that. So I can show you the distributing. I multiply here, 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 and here. So cosine xy times x dy dx. Okay, the easiest way to write that is x cosine xy dy dx. And then this times this is y cosine xy equals. This thing times 1 is just the same thing, negative sine x plus y. And then this times dy dx. So negative sine x plus y dy dx. Okay, great big mess. All right, now I want all the dy dx's on one side and everything else on the other side. Okay, I decided to move this thing over here. So all the dy dx's are on the left side. This thing does not have a dy dx. I'll move it to the right side. This thing already does not have a dy dx, so it stays. Okay, so this thing moves over and becomes a positive. This thing moves over, it becomes a negative. Unfortunately, I'll have 2 negatives here, but that doesn't really matter. You're either going to have 2 negatives here or 2 negatives here. Okay, so negative sine x plus y, that stayed. This plus becomes a minus, minus y cosine x plus y. And now that moves over to this side. Okay, so this thing has a dy dx. This thing also has a dy dx. So if I factor out the dy dx, I now have x cosine of xy plus sine x plus y equals that thing minus that thing. Okay, so you can see how bad this one is. All right, so last step, divide both sides by this. dy dx is equal to, here we go. Here's the numerator, negative sine x plus y minus y cosine of xy, all divided by this mess, x cosine xy plus sine, parentheses, x plus y. Okay. All right, so I'll stop there. I'll check the chat also, but Prasanna may have already gotten some of that. Just so you know what we're headed for tomorrow, same thing, except they want the slope at a particular point. So this time you're going to plug in 2 and 1, because chances are your derivative is going to involve x and y also. Okay, but I'll stop here for now. And let me see if anybody has questions, and I'll check the chat also. Okay, so let's see. 3.453. Okay. See, did I already do that one or not? Let me double check. 3.453. Yeah, sine of x. So yeah, thanks, Prasanna. You pretty much got it, because it's going to find a while to get this. So keep in mind when you have sine of x, that's not a multiplication. Okay. In order for it to be multiplication, you would have to say sine of x, or sine y, sine x. This is a function inside a function, f of g of x. Okay. So you take f prime of g of x, cosine of sine x, and then times the derivative of the inside function, which is cosine x. Okay. So this is a composition of functions in that situation. Okay. All right, and that looks like that's that. Anything else in the chat? Okay, thanks, Prasanna, for helping me out with some of these. Okay, so I can take any other questions, and if not, we're done. Time is at 12:52-ish. Okay, anybody want to see any questions? Otherwise, we're good. So So I've started implicit differentiation. I'll do more next time with that. So I think we're okay time-wise. Okay, anybody else with a question, please? If not, we're done. All right, I don't hear anything, so let's call it a day, folks. All right, so we're done. Thanks, everybody. Have a good day, and we'll see you all tomorrow. Okay, thanks. Bye.
Thank you, Professor.
Thank you.